Hi, I'm Dave from Gen AI Partners. Before we go to the video, I want to give you a little bit of background on our company. Gen AI Partners, we are a product and engineering consulting firm focused exclusively on generative AI, which gives us an advantage in a few areas. One, the landscape is changing so rapidly right now, it helps us keep on top of the latest tools, both at the API level and product level, that are available to builders in the ecosystem today. Secondly, we spend most of our time doing either research or delivering custom projects with generative AI. So we find all of the small functional gaps and pitfalls, as well as the tips and tricks that work to make your generative AI products and features work the way you want them to. And lastly, we have deep experience in traditional technologies, building out data pipelines and SaaS solutions at many large to small companies. What are the typical projects we see? It's still new in the ecosystem, so a lot of people are experimenting. But some of the things that we see working right now are on the brand side, building unique experiences as part of your campaigns where customers and prospects can interact with AI in a more realistic way than ever possible before. Custom knowledge bases and creation tools that help complement your existing workflows. And really, anywhere where you want to plan, architect, and deliver features to your existing software, we can help you identify what will work and what won't work. So we're here to help support any custom project or POC. If you want to reach us, here's our contact information. Look forward to working with you. Today, we're going to be going through how to build an AI-powered SMS chatbot in a real-world scenario. An SMS chatbot powered by AI at a high level will provide an SMS interface to the GPT-3 engine that people have come to be familiar with through ChatGPT. We're going to add a few features on top of what are available in the base model, some of those through additional programming, some of them through prompts. We'll go through that in the tech explanation, but we'll give the agent a short-term memory as well as a custom persona that we feel like matches with the brand. And then we'll get through a couple examples of where you could extend the functionality to add in some more traditional feature sets for chatbots like promotion delivery or contact list building. Before we get in, chatbots are not new, so we want to talk about kind of the existing technology. So the diagram on the left is from the Intercom website, one of the bigger providers in the flow-based chatbot space. So AI chatbots are not the solution in every scenarios, but with the example we show, we do feel like they're a good fit. Where we generally see AI chatbots excel is where you need to handle a broad set of requests tapping onto unpredictable and diverse knowledge sets, where you want a human-like experience, and especially in service industries, where you may want to mimic characters or personas that complement your brand and really help with your marketing and customer engagement. Flow-based chatbots still have plenty of use cases that are out there. As you can see in the diagram, they're really experts in managing plan flows and getting you to specific information or specific subagents or human support after a couple attempts and more complicated flows. And where people are in kind of high risk scenarios or have legal or need a extremely constrained experience, they provide a lot easier way to constrain the interactions that the bot can present. Within the AI chatbot realm, it's not a one-size-fits-all. So, the chart to the left that we put together, really shows how through different implementations, you can change the predictability and the breadth of topics that are covered by the AI chatbot. So the one we're going to show today, it sits in the top left, where we'll be providing a custom index of knowledge as well as prompt templates that define the personality. And then on the bottom right, you'll see basically where you could build a chatbot that essentially just passes through prompts to the GPT-3 engine or another large language model of your choice. And there's areas in between where you can constrain that with prompt templates that are hidden from the user, and where you just add an index, but not necessarily the prompt templates that add further constraint. And really at any level, there are also controls in terms of creativity through the form of the temperature and hyperparameters of the language model. So we'll go a little bit more in depth, but one of the things we see being misinformation in the ecosystem sometimes is that anytime you provide AI, you run the risk of kind of high-risk conversations that can go anywhere, like people have dug up with ChatGPT and the new Bing interface. So the demo we're going to go through today is a real-world scenario where we've taken a real website and knowledge set and put together an example that we feel like would be useful. It's not being used live by the customer. We picked a chain that we love instead of a live client, so we could share this more broadly. But just to give a highlight of the problem set, it relies on a lot of specific knowledge. So restaurant chains obviously have menus and locations and hours that are specific to them and may be updated more frequently than the language models themselves with critical information for the users. In their existing context where most questions get answered either in person or on the phone, they have a tough solution where wait staffs and hostesses are being asked to answer questions while they're also trying to wait tables or book reservations with a lot of noise in the background. So definitely a dedicated experience that's available 24/7 and kind of in a calm and knowledge heavy environment could definitely add a lot of value there. And then the last piece, obviously everything digital is more highly documented and can be studied. So you can find gaps in your website, where there aren't maybe dietary restrictions, other things that people can serve up and could be reviewed periodically to understand how to better deliver that through a passive experience. So we chose Little Greek Fresh Grill, a medium-sized restaurant chain that we love. And we set aside a few key goals that we wanted to accomplish in the hypothetical scenario. So we wanted to create an interesting persona, which we've mentioned. I think that's an underrated feature of the language models, where you can choose to make them really any person or personality that you want. It's obviously available 24/7, both to inform and entertain. We wanted to add a kind of micro feature where they can present a promo code that's hidden in the conversation, so kind of a fun way to surface promotional materials, and create logs and insights on customer questions. And potentially you could expand for SMS promotion lists. We won't show that in the demo. You need a little bit more custom flow to allow for opt-in and recognition there, since you have to get approval to collect phone numbers for marketing purposes. So this is an AI generated image of Stavros. So we're going to try to have some fun with this. And so our solution will present a SMS accessible chatbot Stavros. So you won't see him in the demo. This will be the only time you see him, but he'll be able to access information from the menu, the locations, and the company information, as well as extend to information that's present in the underlying language model. He'll have the kind of jovial personality of a Greek grandpa from Mykonos, and he'll remember conversation between multiple texts. And if you ask about Mykonos, he'll give you a promo code because it's one of the topics that he loves talking to. So we're excited to show you it in action and talk a little bit more about how the technology works and how easy it is to put together.
Hey everyone, I'm Karl from Gen AI Partners, and we're going to go through the technical overview as Dave stated. Let's get right into it. So Dave mentioned we're going to build this AI powered SMS chatbot as a custom application. And you may wonder what makes it custom? Well, the obvious, the data source is custom. The restaurant's website, it has its own menus, its locations, its FAQs, its culture and values. And what's also custom is the agent itself. A custom persona, Stavros, that grandpa who grew up in Mykonos, who's going to actually tell you about the restaurant and what makes it so special and what he loves about the restaurant as it's reflective of his background. And so to do all that, we're going to actually allow you to interface with it through a simple SMS interface that can be done through Twilio. That'll be like a minute. Most of the work is in the back end. How we enable that composability through the custom data sourcing, the indexing of the embeddings that allow semantic similarity search to be possible, the agent persona that we can dynamically embed at runtime and even alter, depending upon the differences in conversation or intent or purpose. In this case, Stavros will be jovial. Finally, we're going to have a promotional tactic employed to show you that it's not just about an agent that's service oriented, but just like in real life, we have human service agents that sometimes offer a promotion to spur interest, loyalty, or just increase demand. We're going to have Stavros do that under a certain condition if you ask him about his hometown Mykonos. Anyway, let's get rolling. Let's take a look at the logical architecture. Now, as you can see, we break it down into that front SMS interface, which is pretty simple. And I built it here on the laptop, tunneling in securely through ngrok. If you were in production, you would obviously want to do it with something more sustained and long-lived, like a unicorn connection. But in any case, we'll show you how you can assign the webhook through ngrok in that Twilio configuration. But most of the meat is in the back end here, where we actually develop the service bot. Now, just as an FYI, we're not going to do a Flask web interface as well. We'll do that another time in a future demo. So let's get over to Twilio. Let's just do the simple configuration so we can tunnel in, and then we'll follow up and talk more about the implementation details here in the back. So here we are in Twilio to configure our SMS interface, and it's simply in messaging. We want to actually set up a service, in particular a sender, and we can do that by pulling up our service bot and then going to the sender pool, pulling up the actual number that we've set up to on behalf of the restaurant. So assume this is the restaurant number, and you're going to see in future part of this overall demo series that Dave is going to walk through an exchange, interacting with the SMS through his phone. Now, in this phone, we configure a number of things, including for voice, which we're not going to demo today, but for messaging down here, our service bot, we're going to have a webhook where ngrok is going to actually provide a URL that the SMS messaging service can actually call. So when you call the number, it'll get routed through this particular URL. But first of all, we actually have to bring that up. If we're going to bring up ngrok, which I've downloaded locally on my desktop, we can set calls to come in at port 503 or 5003. And what you need to do, and this is just for local, again, on Gunicorn in a production scenario, you would have a longer lived URL for the webhook itself. Just bring it in as we bring this particular webhook live. Save it, and now it should be operational. And you'll see Dave use it momentarily. So, as we discussed before, the Twilio configuration is the easy, simple part, the repeatable part, the standard part. The real customization, the real work happens behind the scenes, and yet it's so simple. But there are implementation considerations that need to be pondered, and in this case, we made selections just for the purpose of the demo, but we have an opportunity to refer to other options along the way. Now, if we read this from bottom up, we can think about it from a process standpoint, preparing the inputs. Now, an input, in addition to the custom data source, is the prompt itself. For those of you unfamiliar, you can prompt the service bot to really guide and instruct exactly what they should do, how they should behave. But we'll discuss that more later. When we talk about the actual data source, a custom data source, one that you don't go to GPT-3 for, but rather you just simply source directly from a restaurant's website, we actually prepare data files for the menu, for the locations, and the FAQs that you want to have questions and you want your service bot, Stavros, to answer accurately and quite pleasantly. Now, we did this for demo purposes of preparing these text files manually, copying and pasting it into a file, and I'll show you what that looks like, stored locally on this desktop. But if you had a frequently changing data source, one with rapid evolution, maybe it's a weekly menu at a particular restaurant, or there are a number of use cases that require rapid evolution of the content, you'd want to create something more automated. And we'll come back and in the future demo exactly that. And there are many different data connectors already out there ready for use. Llama, or formerly known as GPT-Index, has a hub of data connecting tools. And they have one with web scraping that uses Beautiful Soup out of the Python library. And Langchain even has a Beautiful Soup version through its web-based language module and another request wrapper. We'll look at least one of them in a future demo, but bottom line is frequently changing source, automated. Now, after you prepare the inputs, you actually have to go ahead and index it, have embeddings. And if you don't know what an embedding is, it's really a vector mathematical representation that tells you how similar it represents a point in vector space where if your question is close to that point in vector space, you have semantic similarity, and it knows to pull up that content as a part of the response. So we prepared the data inputs. We're going to actually run it through an indexer, and we're going to use a GPT-Index toolkit for just that. And it's very effective for not just generating those embeddings, and we do store them again locally in our file system. You could do it locally on an S3 system, or more importantly, or more effectively for something high volume, you may want to actually consider a vector database like Pinecone, Alleviate, or something else. And that'll be a future demo that we'll show here as well. Now, the ability to index those embeddings for rapid and accurate responding is enabled, obviously, through the agents calling it and querying it. So we do a few things here. First of all, we use the GPT-Index tool to be able to, at runtime and during the exchange, query these embeddings. But then this agent that we are constructing is built using OpenAI's embeddings and completions APIs, and it's on top of the langchain library that allows us to create an agent with memory, with chaining capability. And to bring more of a tangible, concrete example of that, we're going to now go over to the code. So let's prepare the inputs, step one. So here we have, under our data folder, a number of files, text files that we prepared manually because it's just for demo purposes, and the menu doesn't change that frequently at Little Greek Restaurant Bar and Grill. Now, if you have a restaurant that has a weekly menu, you'll probably want to automate it like stated just moments ago. But here in the FAQs, you'll see some questions and answers that will be indexed along with the hours, locations, values, and menu. Now you'll notice things like do you deliver, and there's a random word collapse that was just copied out of the HTML. And bottom line is it will be ignored, through the concept of attention. The language model will know to ignore certain words that don't have a high propensity to exist after words that come before it or after. So we've got in hours, we just use for a single location what the hours were, just for simplicity. Even locations has information at the bottom of a web page that got caught in there unintentionally, but we didn't worry about it. You don't have to clean it up. Attention to the rescue, as the LLM knows what to ignore and what to focus on. The culture and values, the menu itself, and I'm gonna have a lot of questions, right? I have a lot of dietary restrictions, dairy-free, gluten-free, soy-free, you name it. So it's important for Stavros, our friendly, jovial service agent, to know these answers and to answer my questions directly. And then, you run the indexing program, it will generate an output. And here's an example of it that's in JSON format. And you'll see down here basically the vector representations of points in space. And obviously the incoming question is close to the vector points of a response. In other words, semantic similarity is pretty close. Then, Stavros will know that's the answer and pick it up and deliver it to you. All right, next we'll take a look at the code for actually indexing and, excuse me, then go over to the bot and build it. So let's start indexing. And we do have a file called indexing that we run once to generate the indexes. As long as the data hasn't changed, we only have to run it once. So we'll run it on our folder called data, pass it into this function create index, which basically then gets the credentials to go to the OpenAI API and then pass the folder that was passed in. It's really, again, that folder of data or inputs that we generated into generate index. And really all that you need to know about that is, as we pass in those pages and we define some parameters of how we want to do the indexing and embedding, we define the prompt helper according to those constraints. And then basically feed in the documents and the prompt helper into GPT-Index's GPT Simple Vector Index. So it's a function that takes in all those parameters you see on the screen. We only have to submit 2 parameters, documents, and in this case, the prompt helper to guide the construction of it. Next, we'll go over to the service bot and begin building that bot. All right, so let's build the agent. So here we are in our service bot script, and we're going to leverage the index we just built. Basically loading from disk the index.json file we created that had those vector representations of the embeddings to show the semantic similarity to incoming responsive or questions as they come in. Plus, what does our bot need? It needs memory. We're going to use a conversation buffer memory from GPT-Index. Actually, it's out of the langchain library directly. And there are 4 different types of memory we could have chosen for this. This is the first, and there's a windowed version of it as the second. And then there are 2 more for conversation summary buffer memory, and then another windowed version of that. And windowed meaning the last X interactions are captured, just sort of a, first in, first out concept, but not creating this extended memory forever. And now between those inputs that we've got on the index and now setting up memory, let's take a look also at the prompt before we now build out our agent to use the memory and index that we just defined. So here's our Stavros prompt template, and we initiate the creation of one of a prompt template of Stavros based on it. And you can see in the format of it, what we've done is we've developed this prompt and we're using dynamic variables. So this should be nothing new to those who understand the aspect of at runtime providing the input variables. But in this case, we have programmatically a bio already predefined in which we're going to insert using this bio text. And what it does is basically define who Stavros is. So the bot needs to get to know his own persona. He is Stavros, a 73-year-old grandpa from Mykonos, Greece. He has interests. He has his favorite food, pastisio, a number of other favorite foods, hobbies, and generally someone who loves his culture and is very jovial and somewhat gregarious on the discussion, while at the same time keeping his outgoing nature to 3 sentences or less. Now, the bio is actually something that could be played with from a development perspective, and some interesting use cases are going to come up in the future where we may change the persona dynamically depending upon the nature of the conversation. But stay tuned in future demo instances when we do that. So coming back to the service bot bio where we define the prompt, the bio is inserted dynamically, chat history is dynamically captured ongoing, and of course the question always takes on the incoming message. And using that prompt, we'll be able to actually combine that with the inputs of Little Greek Restaurant's website and provide our service agent both the persona and the knowledge to answer questions. All right, so now that we've seen how we're prompting the service bot, we're providing those instructions on how to behave, informing dynamically through the bio text file what the bot, who the bot is, Stavros, our 73-year-old jovial grandpa, and defining memory as that ongoing chat history cumulative collection. We have the seeds in which Stavros can answer the questions coming in from first to last. Now, the way it's implemented, of course, is when an incoming question posts to the endpoint of service bot that we set up through Twilio earlier, we'll capture that incoming message. We'll do that test to see if there's a reason to give them a promo code. If the customer had asked about Mykonos in any form, like, how do you like Mykonos, Stavros? Stavros will reward the user with the code for 20% off. And then naturally, whether it's the first question coming in or the final, we have different handling. So if it's the first question, not yet responded, we're going to actually make sure the prompt is fully defined, of course, with that question equaling the incoming message, chat history, getting the running total that we are managing and appending to both human and AI later. We are going to define a tool for this agent to use, and more on this in a bit of what this represents, but this is the querying of the same index, because our service agent Stavros will have two sources of information. One, most importantly, the primary source of information being the context relevant text generated from those input files from step one. But it could be a question of how are you, that you don't need the context relevant information. You know, just like any GPT-3 bot, Stavros can just say, I'm doing great, how are you? So between tools and defining what our large language model will be, which is OpenAI, and you can set the temperature as one of your levers to basically decide the temperature 0 to be more random, or to be more consistent, and 1 to be more random. We feed that into a definition of an agent chain. So we're going to initialize it. This is the first question coming through, you know, with injecting the tools, the definition of our language model, and we're deciding to choose an agent of conversational React description, because in this type of agent, the agent gets to decide, do I need to use a tool or not? And then executes the actual action, excuse me. And of course, the agent chain will have the memory fed in, which includes, as we saw, as a memory key chat history. If for special handling, if this is the second response or more, in other words, Stavros previously had responded and we established that value, Boolean value to true, we'll again define the prompt, but we'll immediately run the agent to actually only do the incoming message. So that's a difference between first time and every time after. The first time we're feeding in the full prompt, but every time after, as we're chaining these instructions, it's just knowing what the incoming message is. And we'll maintain the chat history by appending both human and Stavros, our bot's responses. Okay, so let's summarize. What we did was generate the inputs. We generated the indexable embeddings that created the website context to answer questions for our created agent, Stavros, our service bot, who needed the knowledge of the website, needed instructions through a prompt, and needed memory to capture the interactions between himself and the human answering the questions as the inputs came in through SMS to the endpoint service bot. And I bring you back here for a reason. Number one, or mainly the primary message, is composability. We were able to bring custom knowledge through the inputs, but the composability of the agent to have a very specific persona through the bio dynamic variable, basically run or filled at runtime, along with the enablement of agent chaining, which we just showed you chaining today of the interaction between human and AI service bot. But you can chain to take actions that actually integrate with other systems, a customer service system, a marketing system, maybe it's a sales pipeline system, many other options as well, notifications on Slack. Dave and I are going to come back and give you demonstrations of how dynamic and how composable these applications are. Now, one other aspect to consider is we did use the agent chaining concept with a very special agent type conversational React history, but there are other ways to go, including different modules by langchain, like the LLM model, and there's also a multi-input source model. So Dave and I will also show different technical tactics, and we'll talk about use cases and which one is better than the other as well. Now, just keep in mind, if you are going to play with LLM chain, there have been a number of issues already raised on the langchain repo with issues about parsing output. So as that gets settled in, we'll come back as well in terms of a stable version, and then come back and show you how to use that particular module. Anyway, let's go over, check out how Dave simulates all this through an SMS interface. You can see it all come together.
So for our last section, we're going to ask a few questions of Stavros and give him a live spin. So we'll start out with some basic stuff and make sure we showcase a couple features that we mentioned. We'll just ask, is this little Greek girl? A lot of people may just want to make sure they have the right number when they first text in. So you can see the response we'll get from him will be, kind of start to show his personality, as well as just provide the answer to the question. So he mentioned Mykonos and some of his favorite foods. So we'll ask him, just for fun, do you like Mykonos? And he does, which is not that surprising. But we also can see that because we asked about Mykonos, we kind of mentioned we've coded this bot to respond with a promo code for people who ask about Mykonos. You could easily set that to questions about ordering or online ordering if you want the conversational promo to be more related to the usage of the code itself. So we'll ask one or two functional questions, and then we'll just ask about whether or not he remembers what we talked about. So ask what they have for vegetarians. There's a typo in there, but you can see one of the good things is a few typos or lack of punctuation doesn't matter with the AI because they generally get the gist of things pretty well. So you can see it successfully responded with a couple dishes which have kind of no meat in them: the Greek salad, spanakopita, moussaka, falafel, vegetarian stuffed peppers. And so to wrap things up, we'll just show and see if he remembers what we talked about. So us just directly in this case. They also do use that less directly. So it's great. He gives a kind of a quick summary. We talked about him, Mykonos, the vegetarian and vegan dishes we offer, and he gives you a reminder on the promo code. And so that's Stavros. So hopefully that gives you a little bit more of a live demo of some of the things we showed in the business and tech overview. Thanks for joining us for today's demo. And some of the future demos will show a little bit more depth on what you can do with personality and memory and kind of the depth of experiences that you can offer, as well as kind of how to add a web interface instead of a SMS interface.